Hey y'all. I wanted to make a quick video for you to help you with a last thing in section or module 7. Yes. Um, so hopefully on in tomorrow's class we should get through all of the graphing. There's one last little section with even and odd functions that I don't think we'll have time to get to in class. So I wanted to make a quick video for you. This won't take much time. Just want to let you know what even and odd functions are and connect that with our trig functions here. So an even function. What an even function really is in mathematics is any function where f of negative x is equal to f of positive x. So what that means is that whether you put a positive or negative value into your function, you get exactly the same y value out. And so what that means graphically for your function is your function is symmetric across the y-axis. It means that your y-axis, right, that vertical axis, it kind of acts like a mirror. So if you fold the right half of your graph over the y-axis and you reflect it horizontally, the left side of the graph is a mirror image of the right side of the graph. So you're symmetric across the y-axis. That's what that means. The right and the left sides are mirror images of each other. That's what an even function means. An odd function mathematically means that f of negative x is equal to negative f of x. So what that means is that when you plug a positive number and a negative number into your function, you get the same number but with opposite signs. So one's positive and the other is negative. So this is what the notation looks like for that. And graphically, what that means on your graph is that your function has rotational symmetry about the origin, the point 0, 0. Okay, if it has rotational symmetry about the point 0, 0, what that means is if you took the right side of your graph and you rotated it 180 degrees, then it would match the left side of your graph. So it has rotational symmetry about the origin. So if you take the right side and you rotate it around a circle 180 degrees, the left side would match. If you took the left side and rotated it 180 degrees, it would match the right side. So these have rotational symmetry. So if we look at some of our functions here, let me go all the way back to the top. Okay, so we have that the graph of sine of x looks like this, right? And it's going to continue on the other side like this. So this is what sine of x looks like, right? We graphed that earlier. Is the right side and the left side, are they mirror images of each other? Nope, because if they were mirror images of each other, so let's just say this is what the right side looks like, right? If they were mirror images of each other, the left side would have to look like this, right? It would be a mirror image. That's not what sine looks like. So this is not a mirror image. This is not an even function. Does it have rotational symmetry? If I took the right side and I rotated it around. So if I took this side and I rotated it 180 degrees, then this axis would end up down here and this axis would end up here. You're going to rotate it 180 degrees around. If you did that, this side would end up down here and this side would end up here, right? When you rotated it 180 degrees. And notice that is exactly what the left side of this graph looks like. This has rotational symmetry about the origin. This thing is odd. This is an odd function. So sine is odd. How about cosine? So we know what the cosine graph looks like. It starts up and then waves from there and continues to wave on the other side. Okay, so that's roughly what cosine looks like. Now, does this have, is it a mirror image? So if I took this side and I flipped it over and I reflected it on the other side, then the other side would look like this, right? This is the mirror image of that. And notice that is exactly what the left side of this looks like. This is a mirror image. This is an even function. Does that make sense? So hopefully graphically how we defined these guys makes sense. So if I come all the way back down to here, we just said that sine was an odd function. And actually, instead of writing sine that way, sorry, let me actually put this in as y equals the sine of x. I'm going to do it that way. So sine is an odd function and cosine was an even function. So cosine is even, sine is odd. And again, if you go back and look at some of your other graphs, what you'll notice is that because cosine is even, secant, its reciprocal function, is also even. You'll notice that secant, the right and left side of the graph, is a mirror image again. So secant is right here. Here's your y-axis. Notice that your right and left sides are mirror images of each other. Secant is odd. Oh, sorry, even. Secant is even. And then the rest of our function, our trig functions, are actually odd. Because sine is odd, its reciprocal function of cosecant is also odd. Tangent is also an odd function, and its reciprocal function of cotangent is also odd. The rest of these guys are odd. And if you went back up here and you looked at some of our functions here, here's my y-axis. Notice if I took the right side of this graph here and I rotated this 180 degrees, so this came down here and this rotates up here, this part would rotate down here and this part would rotate up here. So this has rotational symmetry. It's odd. And you can check tangent and cotangent as well. They're odd functions. So now that we know what's even and odd, we're going to use these mathematical definitions of even and odd to apply to our functions. So we've got some numbers here, and I want to find the cosine of negative 2 pi over 5. Well, because cosine is an even function, and even functions mean you get the same thing whether your x value is positive or negative. If I have the cosine of negative 2 pi over 5, that is exactly the same as the cosine of positive 2 pi over 5. So really that's all this wants you to do. It doesn't want you to put it into the unit circle or anything like that. It just wants you to write it with a positive input. So the cosine of negative 2 pi over 5 is exactly the same as the cosine of positive 2 pi over 5. How about the next one? The sine of negative 7 pi over 6. Well, sine is odd. So since sine is odd, I'm going to use this definition of an odd function. The negative moves from the inside to the outside, which means the sine of negative 7 pi over 6 is negative sine of positive 7 pi over 6. So that negative moves from the inside to the outside. That's kind of what an odd function does algebraically. All right, and then the last one, how about the cotangent of negative 85 degrees? Well, cotangent here is odd, which means I'm going to use my equation here. The negative moves from the inside to the outside. So this is the negative cotangent of a positive 85 degrees. That negative moves from the inside to the outside, and these are the expressions that Alex is looking for. So I hope that helps you with module 7 and finishing that up. Have a lovely day, and I will see you next time.